Section 8.4, to define and use the sine and cosine ratios to find the side measures and angle measures of right triangles. Here we're given a diagram of a right triangle, triangle ABC, where C is the right angle, and we've identified parts of the triangle compared to a specific angle. Of course, just like the tangent ratio, we have to select an acute angle. Here we have selected angle B. From angle B, we have identified the parts of the triangle. For example, segment BC is the adjacent leg. Segment AC is the opposite leg to angle B. And of course, opposite angle C, which is the right angle, is our hypotenuse. Then what we do is define the sine and cosine ratios. The tangent ratio was defined in the previous section as opposite leg over the adjacent leg. Here, we're going to incorporate the hypotenuse into these two trig ratios. First, the sine ratio, the sine of angle B. This is identified as the leg opposite angle B over the hypotenuse. Cosine of angle B is the leg adjacent to angle B over the hypotenuse. Or we could write a shortcut as opposite over hypotenuse. Of course, we don't have to write a leg because we already know that. Here we could write adjacent over hypotenuse. And what we want to do is determine angle and side measures in similar fashion as we did in the trig ratio of tangent. On this example, we want to write the ratios of the sine and cosine of angle X and angle Y. Here we have the sine of angle X and the cosine of angle X. Let's identify the triangle based on the acute angle X first. So if I have angle X, I can identify that segment YZ is the opposite leg to angle X. Segment XZ is the adjacent leg. It's the one that helps form angle X. It's the one that's closest to it. And of course, opposite the right angle, which is Z, is our hypotenuse, and that would be segment YX. Now all I need to do is to substitute into the appropriate ratio for sine, which is going to be the opposite leg, which here is YZ, over the hypotenuse, which is YX. For cosine, that ratio would be the adjacent leg, which is ZX, over the hypotenuse, which is YX. Next, to complete the ratio for the sine of angle Y and the cosine of angle Y, I need to identify the parts of the triangle based on the acute angle Y. Here, I have segment YZ. That's going to be the adjacent leg to angle Y. The opposite leg is ZX. Again, I know that point Z is my right angle, therefore YX is my hypotenuse. Now I just substitute into the ratio for sine, which is the opposite leg, and here the opposite leg is ZX, and the hypotenuse is YX. For the cosine of angle Y, I know the ratio is the adjacent leg, which is YZ, over the hypotenuse, which is YX. On the next example, they want us to determine the sine of angle X and the cosine of angle X. We first need to identify the sides compared to angle X. Here, I have angle X. Y is my right angle. Therefore, 2 square roots of 15 is going to equal the hypotenuse. And with angle X, I have the measure of 6 representing segment XY being the adjacent leg. It's the one that helps form angle X. It's the one closest to it. Therefore, the measure of 4, which represents segment ZY, will be the opposite leg. Now I just substitute into the correct ratio. I have sine of angle X, that is the opposite leg. That would be 4 over the hypotenuse, which is 2 square roots of 15. And for cosine of X, that's the adjacent leg, which is 6 over the hypotenuse, which is 2 square roots of 15. Normally, we would take care of the radical in the denominator, but our calculator will take care of that when we actually get to that point in our examples. As we did with the tangent ratio, we want to be able to determine side measures. we want to do the same thing, but instead of the tangent, we want to use sine and cosine ratios. Our procedures are very similar. The first thing I need to do is select an acute angle. Again, it doesn't matter which one I use, as long as I associate that with the correct sine or cosine ratio. Number two, I need to determine the hypotenuse, the opposite and adjacent leg compared to the angle I selected. Number three, substitute the three needed values into the appropriate locations in the sine or cosine ratio. Number four, I want to solve the unknown variable. I want to do that as I did before, which is create a ratio, use a cross product, and solve by either multiplication or division. Then, since I'm solving for a side, I'm going to enter the expression opposite my variable as shown into the calculator, and that will give me the value for the side measure. On the next example, they want us to find the value of x, round answers to the nearest tenth. The first thing I need to do is, of course, identify an acute angle. Here they have one for us, which is 62 degrees. I'm going to show this example both ways by solving for the 62-degree one and using the other acute angle by the triangle sum theorem. Let's start with a 62-degree angle and identify the sides based on that angle. Here I know that x is a leg, and in this case it is the adjacent leg. 20 is opposite my right angle, so therefore this is my hypotenuse. Now, what I need to do is not only select the angle I need to use, which I already have, which is 62 degrees, but also choose the appropriate trig ratio by the sides that are given in my diagram. Here the sides are adjacent, leg, and hypotenuse. That is associated to my cosine ratio. Therefore, cosine of 62 degrees equals the adjacent leg over the hypotenuse, which is 20. Solve for x by creating a ratio on the left side and using the cross product gives me 20 cosine of 62 equals x. Now that I have solved for my variable, this is a side, so all I need to do is to substitute that into my calculator and get a value for x. And here, 20 cosine 62 degrees. And I press enter, and rounding to the nearest tenth, I get 9.4. So using the cosine ratio, I get x equal to 9.4. Now what I want to do is to solve this problem using the other acute angle to show you that it doesn't matter what angle I use, as long as I use the appropriate trig ratio that corresponds to the known sides. So here, this is 62 degrees and this is 90. I'm going to use the triangle sum theorem, and when I do that, I'm going to get this angle to equal 28 degrees. Now, I'm going to identify the parts of the triangle based on that angle. Here, I'm going to have x equal to the opposite leg. And of course, 20 is still opposite my right angle, so that's still my hypotenuse. Now, I have an opposite leg and a hypotenuse. That trig ratio, using opposite and hypotenuse, is the sine ratio. So I'm going to have the sine of 28 equals opposite, which is x, over the adjacent, which is 20. Set up a ratio on the left side and use the cross product. I get 20 sine of 28 degrees. And that is my x. Now I just substitute that into the calculator. And when I do that, 20 sine of 28, I should get the same value for x. And if you notice on the screen, I kept the one up here for cosine, and now I have the one for sine, and they are the exact same value, 9.4, when rounded to the nearest tenth. Therefore, it doesn't matter which acute angle you use, as long as you use the appropriate trig ratio associated with the identified sides of the triangle. In my next example, again, they want to solve for x, that is a side measure. I'm going to select 48 as my acute angle. It doesn't matter which one you select. I chose 48. Let's identify the sides based on that angle. Here, opposite my right angle is my x, which is the hypotenuse. And the known side is 11, and that happens to be the adjacent leg to angle 48. My ratio that corresponds to adjacent and hypotenuse is cosine. So cosine of 48 degrees equals adjacent, which is 11, over hypotenuse, which is x. Set up a ratio on the left side, use the cross product, gives me x cosine of 48 equal to 11. Divide by cosine of 48 on both sides. And I get x equal to 11 over cosine of 48. Now, since I'm solving for a side, I just substitute that expression into my calculator. Here I have 11 divided by cosine 48. And that equals, when I round to the nearest tenth, 16.4. Therefore, x is equal to 16.4. Again, I want to use the other measure of 42 degrees to verify that that works out. You don't have to do this, but I like to verify it so you can see that no matter which angle I use, that it will always work out as long as I use the appropriate trig ratio. Here, compared to the 42-degree angle, the 11 is the opposite leg. Again, x is my hypotenuse. And opposite and hypotenuse is associated with the trig ratio of sine. The sine of 42 degrees equals opposite, which is 11, over the hypotenuse, which is x. And when I set up a ratio, I'm going to get x sine of 42 degrees equals 11. Divide by sine of 42 on both sides, I get x equal to 11 over the sine of 42. Now I just substitute that into my calculator. I have the previous expression still there. This should equal the same value, 11 divided by the sine of 42 degrees. And notice that it works out to be the exact same value, 16.4. The last two examples I've been working out with both acute angles to represent what we're doing on this slide. Here, this is an equation that is true for all values of x, an identity equation. And what I've been showing is that the sine of angle x equals the cosine of 90 minus x. And what I've done is stated that on the previous slides that if I have angle x and if I use the sine of angle x, that equals, when I set up opposite, which is 2, over the hypotenuse, which is the square root of 13, is equal to the cosine of this complementary angle, which is 90 minus x. So when I set this up, I would have the cosine of 90 minus x degrees. And I know that because this would be adjacent, which is 2, over the hypotenuse, which is the square root of 13. And both instances would give me the same value for x. And you can see that on the previous slide. Cosine of 48 is 11 over x. And the sine of 42, which is 90 minus 48, is 11 over x. And when we plugged into the calculator, our values turned out to be the same for both. Therefore, the sine of an angle and the cosine of the complement of that angle are equal. Therefore, an identity equation. One more procedure to follow, and that is to find an angle measure using the sine and cosine ratio. What we want to do is use a variable for the angle you want to determine. Number 2, determine the hypotenuse, opposite and adjacent leg to that angle that you've selected. Number 3, substitute those values into the sine or cosine function that is dependent upon the legs that are given to you by the angle you selected. there will be a variable in the place of the angle. Number 4, what we want to do is press second sine or cosine, then enter the ratio that is opposite that expression. That will give you the value for the angle you want to determine. Let's look at an example. Here we want to find the value of x. Round the answer to the nearest degree. X is given as an acute angle in this right triangle. What I want to do is identify the legs and hypotenuse associated with that angle. Here I have 3.4 as a measure of a side. That is defined as the opposite leg to my given angle. Since 7.8 is opposite to the right angle, this is the hypotenuse. Now I have to determine what trig ratio is associated with opposite and hypotenuse. That is going to be the sine ratio. So the sine of x equals opposite, which is 3.4, over hypotenuse, which is 7.8. I do not solve for x. This is already solved for. Remember, sine and x cannot be separated by any fashion, multiplication, division, addition, or subtraction. It stays as it is. This is solved for. What I need to do is to enter this expression into the calculator. But I have to follow the procedure for finding an angle. And finding an angle, I press second, enter the trig ratio I'm using, which is sine, and then enter the ratio, which is 3.4 divided by 7.8. And when I hit enter, I'm going to get 25.84. And 25.84 rounded to the nearest degree is going to give me 26 degrees for angle X. Our next example, I'm given X as a degree for my acute angle. I identify the parts of the triangle based on that acute angle. Here, 1 is going to be my adjacent leg, 2 is my opposite leg, and the square root of 5 is my hypotenuse because it is opposite my right angle. Now I have to decide what trig ratio I want to use. If I want to use the adjacent leg, then that means I need to use the hypotenuse and the adjacent leg with cosine. So therefore, cosine of x equals the adjacent leg, which is 1 over the square root of 5. Substituting that into my calculator because that's an angle. Second, cosine, 1 divided by, for square root, I press second and the x squared symbol for the square root of 5. And then I close the parenthesis, enter. I get 63.4 degrees, or round to 63 degrees. Is there another way of doing this? Let's take a look if I chose to use the opposite leg in the hypotenuse. That would be the sine of x, which would be opposite, which is 2, over the square root of 5. Finding an angle, I know I need to substitute that into my calculator, which would be second sine, which would be 2 divided by the square root of 5. Press enter, and I get 63.4. When I round, again, I'm going to get x equal to 63 degrees. Now, the only other ratio I want to try is the tangent ratio. So the tangent of x. And remember, from the previous section, tangent is opposite, which is 2, over the adjacent, which is 1. Again, we substitute that into my calculator. And we have, when I do that, second tan, 2 divided by 1, I get 63.4 degrees again. And that tells me that x is equal to 63 degrees when I round. So you can see, it doesn't matter which ratio I use as long as I have the appropriate sides and hypotenuses into that ratio. It will work out to have the correct answer. here in each case 63 degrees.